students, welcome to the class. I am Dr. Tirupathi Reddy, Department of Mathematics, B.V. Raju Institute of Technology, Narsapur. In this linear algebra and calculus course, today we are going to learn the Jacobian concept and their associated properties. First we will see the definition of a Jacobian. Let u is equal to u of x comma y, v is equal to v of x comma y be two functions. These two functions are involving two dependent variables u comma v and two independent variables x comma y. Here u and v are dependent variables which are expressed in terms of x comma y. Then the Jacobian of these two functions is denoted with the Jacobian of two functions u and v with respect to x comma y is denoted with j of u comma v by x comma y, or equivalently partial u comma v upon partial x comma y, dou of u comma v by dou of x comma y, and it is defined as j of u comma v by x comma y. It is defined by means of the determinant, and order of the determinant is given by 2 by 2. It is equal to the number of dependent variables involved here. So before to define the Jacobian, you have to ensure that number of dependent variables must be equal to the number of independent variables, and dependent variables should be expressed as a function of independent variables. Then only Jacobian can be defined in the order from u comma v to x comma y. So we have to read this as Jacobian of u comma v with respect to x and y, and it is defined by means of determinant as first row consisting of first dependent variable partial derivatives with respect to all possible independent variables, dou u by dou x, dou u by dou y. Similarly, second row consisting of second dependent variables partial derivatives with respect to all possible independent variables, which is dou v by dou x and dou v by dou y. This is how we define the Jacobian definition. And whatever we defined, it is not just confined to only two variables. We can also extend the same definition for three variables and in general n variables. Similarly, let us see the definition for three variables. So for three dependent variables, u is equal to u of x comma y comma z, v is equal to v of x comma y comma z, and w is equal to w of x comma y comma z. The Jacobian is denoted with u comma v comma w by x comma y comma z, or equivalently dou of u comma v comma w divided by dou of x comma y comma z. This is how we denote the Jacobian, and we define this as j of u comma v comma w by x comma y comma z is equal to, it is defined by means of determinant of order 3 by 3, in which first row consisting of first dependent variable partial derivatives ux, uy, uz, vx, vy, vz, wx, wy, wz. This is how we define the Jacobian for two dependent variables as well as three dependent variables. In general, we can also define for n dependent variables also. Now we will see one important definition. Note, if Jacobian of u comma v with respect to x comma y is equal to 0, then u and v are said to be functionally dependent. In this case, we have to find out the functional relation between them. So if u and v are said to be functionally dependent if the Jacobian vanishes. If the Jacobian is vanished, we can get the function relation between uv in the form of f of u comma v is equal to 0 or u in terms of function of v or v in terms of function of u. So, we are going to get the functional relation between u and v in any of these forms, right. So, if the Jacobian is not equal to 0, then u and v are said to be functionally independent. Functionally independent, right. So, these are the two important points you have to remember for solving the problems associated with functional dependence and functional independence. And now let us see the two important properties of Jacobians which will help us in solving the problems. First property is j into j dash is equal to 1, where j is given by dou of u comma v by dou of x comma y, and j dash is given by dou of x comma y by dou of u comma v. And the second property is, suppose you have two dependent variables u comma v which are functions of some r comma s, and in turn r comma s are functions of x comma y. If you want to compute the Jacobian of u comma v with respect to x comma y, then we have to use the property Jacobian of u comma v with respect to r comma s multiplied with Jacobian of r comma s with respect to x comma y, and these two properties are useful in solving the problems. Thank you for watching. Next class we will see problems associated with Jacobian's functional dependence. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.